In today's class, we're going to take a look at solving these logarithmic equations. And I would say these are a little beyond entry level for this topic. So if this is all brand new to you, maybe check out like an introduction class on logarithms, exponentials, and like the rules of logarithms, and then come back to this class. So we've got these log equations in slightly different formats, but the main approach is going to be solving them by getting rid of the logarithm, maybe by turning it into an exponential, for example, and combining the logarithms using the rules for logarithms. So the key with log exponential equations is really knowing the rules, or sometimes they're called the properties or the laws of logarithms, knowing those, and then also knowing how to get rid of logarithms, which is basically by turning them into their exponential equivalent form. So we're going to work our way through these three slightly different examples. We'll start with the first one here. So the first thing always to check with a log equation is that you've got the same base on all of the terms. If you don't have the same base, that means you cannot use the rules for logarithms. It doesn't matter if the base is numerical or if it's just some unknown variable like an a. As long as they're the same, you can use the rules. So here we've got two logs with a minus in between. We can use one of the rules to combine those to make it log to the base a. Because it's a minus, it'll be x over 7. So if you're not familiar with that, check out the laws of logs class first and then come back to this. But basically, if it's a minus in between the two, we make that into a divide. So we've combined those into one term. So log to the base a of x over 7. Just going to keep the right-hand side the same, log to the base a of 4. In this scenario, where you've got one log on either side of the equation, you can basically get rid of those. You can't do that at this point here. You can't do it when you've got more than one log on either side and other terms as well. It's only when you've got one log and just like one term on either side. So in this scenario, we can get rid of the logarithms to make x over 7 equals 4. So now we've just got a normal linear equation to solve, which we'll do by timesing both sides by 7 to get rid of the fraction and to solve for x. So x is going to equal 7 times 4, which is 28. So quick recap of that one, we use one of the rules for logs to get to this point. We drop the logarithms just by kind of getting rid of them to get to this point, and then we solved. Okay, right, so that's kind of a starting point. So taking a look at this one, looks a little more complex maybe, but similar format. So we've got two logs here with a minus in between. They've got the same base number, so we're good to go basically to combine these. And how do I know to combine those? Well, that's just the way that these questions tend to go. So usually they're designed so that you've got to use one of these rules for logarithms. So just by experience, you'll know what to do there. So we're going to make this into log to the base 2, and we're going to combine these into a fraction. So it'll be log to the base 2 of 18 over x minus 1. Just going to keep the right-hand side the same, log to the base 2 of 9. Notice that we could potentially evaluate that as a number, but this is asking you what power do you need to put on a 2 to make a 9? Well, there is no whole number for that, so we're just going to leave that as it is. But now we've got the scenario that we had up here, where we've got a log of the same base on both sides, so we can just cancel those out. So that's going to give us 18 over x minus 1 equals 9. So it's a slightly more difficult scenario than we had here, but fairly similar actually, in the sense that we've got a fraction and we need to kind of get rid of it to solve the linear equation. I'm going to do that by timesing both sides by x minus 1. If I do that, then the x minus 1 moves over to the other side. It times to the 9, which would give us 9x minus 9. Okay? Just remember timesing that to the 9 to both of those terms. Taking the, well, I'm going to take my minus 9 over to this side. It'll become a plus 9 to combine it in with the 18 to give me a 27. So 27 equals 9x. This is just a linear equation, solving that by dividing both sides by 9 to get 3. So this would be fairly typical flow for like a log, I was going to say log exponential equation, but we never really used an exponential in there. So it's just a log equation. Okay, cool, right, so moving on to our third example, fairly similar format again, slight difference this time, a couple of differences. One is that we've got two logs here with the same base, that's fine if we want to use the rules, but there's no log over here, so it's a slightly different scenario. Also, this log term has got a 2 in front. Having that number in front means that we cannot combine these directly in the same way we made a combination of these two. But there's one of the rules for logs that tells us if you've got a number in front, you can bring that up onto the power. So that's going to become x plus 1 to the power of 2, x plus 1 squared. Okay, everything else will stay the same. So again, if these log rules I'm using seem really unfamiliar to you, you're probably not quite ready for this class, so maybe, again, check those out first and then come back to this. So now we're in a format where we can combine those two log terms. So we're going to get log to the base of 2. This one's going to be a little uglier, I think, than what we've had in the other examples. So it's going to be x plus 1 squared on top over 2x equals 1, okay? So at this point, you've got a couple of different options. You can either introduce a logarithm on the right-hand side, which you would do by rewriting the right-hand side as log to the base 2 of 2 to the power of 1. And that's because if you bring that 1 in front, it stays as a 1, and log to the base 2 of 2 is 1. That's like a fancy log way of writing a 1. So 1 times 1 is 1, so this really is just a fancy way of writing 1. If we did that, then we would have a log to base 2 on both sides, and we could cancel it in the same way we cancelled the logs over here. I'm not going to do it that way. I'm going to do it by switching this log expression to exponential form. In exponential form, this is just, well, just as a reminder, if you have something like log, say log to base, well actually, let me write the exponential first. If you have something like 2 to the power of 3 equals 8, as an exponential, that can be written as a logarithm by expressing it as log to base 2 of 8 equals 3. So there's kind of this interplay between those two. So we are kind of in this scenario here with this ugly looking term, and we want to turn it into this term, this form of term here, which is an exponential. So we do that by just keeping 2 as the base number. We're going to take this as the power, so it'll be 2 to the power of 1, which will just be 2, equals this thing here, x plus 1 squared over 2x. Okay, so I'm just going to take the 1 off of there because 2 to the 1 is just 2. So we need to solve this equation. It's quite difficult, it's quite challenging, but not untypical of this type of question. Times in by 2x to get rid of the fraction on both sides would be 4x. And that's going to leave us with x plus 1 squared over here. X plus 1 squared is x plus 1 times x plus 1. So I'm just going to write it like that. And we're going to go ahead and expand out that bracket, which would give us x squared plus 2x plus 1. You can check that if you're not happy with what I did there. And then this is now basically turned into a quadratic equation, which seems a long way from what we started with up here, but again, not untypical of this type of question. If you've got an x term in here and an x term in here, it's quite likely it will at some point turn into a quadratic equation. So to solve that, what I'm going to do is turn it into a trinomial by bringing the 4x over to the other side. So we're going to get x squared minus 2x, because it would be 2x minus 4x plus 1 equals 0. And okay, I've kind of spun that around as well. I took that to the right-hand side, but I imagined it being on the left-hand side. Doesn't matter if you gather things left or right with these types of quadratic equations, or any equation actually. This is a quadratic equation, like I've said, so we need to factorize it into 2 brackets to solve it. So this one would factorize with x minus 1 and x minus 1, so a repeated factor there. And then solving that would give us x equals 1. So just one unique solution for that one. So that's quite a complex example, but that's the kind of steps you might very well see. So to get from here to here, we used one of the log rules to bring the 2 up onto the power. To get to the next line, we combined those using the log rules. Beyond that point, well, suppose a third line as well, to rewrite this one as an exponential. That was kind of all the log exponential work. Beyond that, this part here was really just quadratic equations. And I guess if you're already taking a class with logarithms in it, you're probably already quite comfortable with quadratic equations. So a quick recap of all 3 there. The key to getting going with these is to know the log rules, to be able to recognize them, to use them obviously correctly, and then somehow, either by dropping the logarithms or by turning the log expression into an exponential, getting rid of the logarithm. And that's really the key to then allow you to get some kind of linear or quadratic equation to then solve for the x values. These are not easy. They take a bit of practice and experience, so definitely check out the practice questions on this topic.